Okay, so this one, right, is an introduction of area under graph. This area under graph is one of the application for integration because we are applying our definite integral on area under graph. So there's quite a bit of confusion. So to set the confusion out of the way, so we got to do some definition. So I will always define area as vertical or horizontal. So I will start by defining a vertical area first. So my vertical area are bounded by vertical line. So when I say vertical area, right, basically there is a curve and I'm looking at the area under the curve, but there is a boundary of a vertical line. It's like the wall, like the wall in your house. So there are vertical wall and the area under graph, right, got to stop somewhere. It is not like a never ending kind of area. So the definition will be the area will be stopped by the x-axis. So it is under the graph, is bounded by two vertical wall, and it is being stopped by the x-axis. Such an area will be found by a definite integral using the x coordinate. So you integrate the equation with respect to the two walls. So you will be having a value. So that value is the value of the area. So this value, right, in this situation, because it's above the x-axis, so it is above the x-axis, it will be a positive area. So you need to know when area will be positive, when area is negative. So another situation will be it's also this kind of area. If you look at the second situation, I also got vertical wall. So this is not what you imagine to be area under graph. To you, the area is above the graph, but it is also being stopped by the x-axis. So it is above the graph, which we take it as under the graph. So in such case, right, we are not talking about the kind of never-ending area. So it's not the never-ending area that we're looking at. So the definition will be it's bounded by the wall, the two vertical wall, and it's also bounded by the graph. And again, it's being stopped by the x-axis. So this area, because it's below the x-axis, it will be a negative area. So the reason why, that means when you redo the definite integral, if you try to do the definite integral, you will get a negative value. But the reason why it is negative is because it's below the x-axis. So you will be getting a negative value. So the area, since our idea of area will be positive, so you got to introduce another negative. So there will be a negative that you need to introduce to ensure that you get a positive value. So negative and a negative will become a positive value. So in the previous, okay, in you are the new syllabus. So in the old syllabus, we don't use this. We use the modular sign. But because it's not within your syllabus to understand modular sign, so your teacher will not mention about modulus. So we add a negative to remove the original negative in the definite integral. So you actually need to know when area is positive or when area is negative. You are supposed to calculate them separately. If you have no awareness for positive area and negative area, you are just going to calculate them like one shot, and then everything will be wrong. So you need to separate out positive area and negative area.